Hello everyone, I'm Siddharthan. In this video, let's understand how we can build a RAG framework for document question answering with LLAMA 3.1 70 billion version model. We will be accessing this model from Groq, and for vector store we will be using ChromaDB, and we will orchestrate all these things using Langchain. So this will be the agenda for today's video, and let's get started. I'll open my Jupyter notebook, and the good thing about this is it's even okay if you don't have like a larger GPU, because we are going to load this from Groq, and Groq has this free tier where you can load this open source models like at free of cost, within that free tier limits. So let's get started. These are the libraries that we need. So first we have this ChromaDB and Langchain Chroma. So these are basically used in order to save our vector embeddings to this vector DB, which is Chroma, and ChromaDB is like a open source vector DB that we can use. And then we have Langchain and Langchain community in order to load the LLMs and load the chains like retrieval chains and so on. And then we have this Langchain text splitter to use either character text splitter or recursive character text splitter, which is used basically to chunk your documents. And then we have this Langchain Groq, using which we will be connecting this to Groq API to load the model. And then we have transformers and sentence transformer for using Hugging Face embedding models, and then unstructured and unstructured PDF in order to read and extract the contents in the PDF. So these are all the libraries that we need. So I have already installed all these libraries, so I'm commenting it out. But if you are running this for the first time, you can run this. So if I run this, I'll get this statement as like requirement already satisfied. So most of the things are already there. So this is done. Okay, so this is the first step. I'll probably comment this again so that I don't see this output over here. Okay, so this is the first step. So I'll share this notebook. You can refer to that in order to install all these libraries, and all these are like the latest version that's present by the time I'm recording this video. So you can go with that same version. So now let's import the dependencies that we need. So first I'm going to import OS. So I'm importing this OS library in order to save my Groq API to the environment variable. And then from Langchain dot document loaders, so document underscore loaders, let's import unstructured file loader. So basically there are different types of loaders that you can use. So there are like this PyPDF loader and so on. So let's just use with unstructured file loader, but you can also explore like other importing document importing libraries. So next, from Langchain dot text splitter, sorry, Langchain underscore text splitter, import character text splitter. So this is the other thing. As I said, this is used to chunk your document. And then from Langchain dot embeddings, import Hugging Face embeddings. So there are like different embeddings that you can use. Say for example, OpenAI embeddings and so on. For OpenAI embeddings, you probably have to use OpenAI API key. So billing and all those issues are there. So instead we can use Hugging Face embedding, which is basically from this transformers and sentence transformer model library that we have seen. And then from Langchain underscore chroma, input chroma with uppercase C. So previously we would be using ChromaDB, but that's kind of deprecated, and we have this integrated version of Langchain and Chroma, and that's what we'll be using now. The next part is from Langchain underscore Groq, import chat Groq. So this is the chat version of the Groq models. And then, so this is used to load the LLM, and from Langchain dot chains, import retrieval QA. So R should be in uppercase. So let's run this. So this should be an underscore. So for just a document question answering, we can use retrieval QA, but let's say in the upcoming videos, we will also be building a chatbot around this document QA, or this basically RAG framework. So in that case, we can use this conversational chain and so on, so that we can use. So that's one thing to remember. So Langchain dot embeddings, I'm getting an error. So I'm just seeing if I made any spelling mistakes. So we have this Hugging Face embeddings, Langchain dot. This shouldn't be happening. Let me check. Okay, I can probably use Langchain community. So I'll copy this and paste it over here. Let's see if this works. Instead of Langchain, we are using Langchain community version. Okay, so there may be some issues with the spellings or something. Okay, so that's fine. So we have imported all the required dependencies, and the next step is saving the Groq API key to our environment variable. So for that, you can go to Google and search Groq. So you can either search Groq Cloud or Groq. So both of that would work. So we have this groq.com, right? So in Groq, you actually have to sign up with an account with Google or something. So here I've already signed up, as you can see here. And once you're in this groq.com, go to this Groq Cloud, which kind of says this developer playground. So I'll click this Groq Cloud, and from here you can generate your API keys. So this is like the key that I already have, and now I'll probably create a new key for this video, and I'll just name this as, let's say, LLAMA 3.1 rag, and submit. So this will display the API key, and you can copy this API key and paste it over here. And for saving this in the environment variable, you can say os.environ, and within square bracket say groq underscore API key, and then you can paste your API key over here. Okay, so this is how you can save your key to your environment variable, but this shouldn't change. This Groq API key in caps shouldn't change, because this is the place where this Langchain Groq will look for the API key. And this is not a recommended approach or recommended way to kind of explicitly paste your key in your code. Instead, you can save this in a .env file or a config.json file and load it from there, so that like your keys are kind of secured. Just for simple demonstration purpose, I'm doing this, but when you're working on your, let's say, a project or something, you shouldn't probably do this. So that's the next step. So first we are importing the dependencies, and the next step is saving the Groq API key. So the next part is loading the document. So here we will be working with PDF files. So for that, we have installed unstructured and unstructured PDF version, and unstructured you can also use in order to read doc files and so on. So for that, you need to install docx version for this unstructured. So those things probably you can refer, but for now we can just work with a simple PDF that we have been working with before. So for this, I'll be using, so this is my directory where my notebook is currently present. So I'm going to paste this PDF file. Okay, so let me just delete this. I don't want this one. So I want this attention is all you need, which is a PDF font transformer that Google has released. So this is the first paper that kind of started talking about transformers and so on. So I'm going to use this. So if you want this PDF, you can just go to Google and search download attention is all you need paper PDF. So that's like simple, or even you can use a different PDF as well. So that should also work. So now I'll say loader is equal to unstructured file loader, which is something that we have already imported, and in the parenthesis you can give the path of this file. So both this llama 3.1, this particular notebook, and the file is in the same directory, so I can just name the file. So here I'll probably go to rename, copy this entire name and paste it in this parenthesis. Okay, so unstructured file loader, so we need to load this, and then say documents is equal to loader.load. So this will load and extract all the contents within this PDF. Let's run this. You can also print this documents and see like what it's looking like. So it's a document version, and we also have the metadata, like what's the source of this page content and so on. So this is like the exact content. So probably I'll delete this, but this is how it works. So we will load this using unstructured file loader and load this in this documents variable in the form of like this document data type that's present in unstructured. So the next step is splitting this text data into chunks. So I'll say splitting into text chunks. So later we will convert these chunks into vector embeddings, and then we will load this to ChromaDB. So if you are not sure about the concept of RAG, I've already made a video on concepts of RAG. So maybe I'll give the link of that video in this video description. You can check that out. So here I'll say a text splitter. So first we need to load the splitter. So this splitter is basically used to split your text into different chunks, and for this we will be using this character text splitter that we import from this Langchain text splitter. So I'll paste this one, and here we have to mention some parameters, like let's say chunk size. So what's the size of each chunk should be, and you can actually play around with these numbers. Maybe I'll just go with 200 chunk size and overlap of okay, I should call this chunk overlap of maybe 300 or 400 should probably work, but again you can play around with this number. So these are kind of like hyperparameters that you can work on and see like which one works for you. So based on this parameters of chunk size and chunk overlap, our text content will be chunked into different smaller pieces, and the overlap is just to make sure that the LLM and our retriever that basically retrieves these vector embeddings understand the relationship between different chunks. So you don't want to do a discrete cut. So you have this overlap so that like one chunk is kind of connected to the next chunk, so things like that. So that's the purpose of this chunk overlap. So I'll run this. So here we are loading the instance of this character text splitter object to this text splitter variable, and now we are going to use it in order to chunk this text present in this documents. So for that you can say text is equal to text splitter, which is this variable, and then you can say so text splitter dot split documents, because our documents is basically in the document data type. So split documents, and within this pass your documents variable, this one. Okay, and let's run this. So this will create chunks of this, and it will store in this variable called as text. So you can also even check the type of this text. So it's a list, and you can also see the length of this particular list. So it says 26, and maybe we can print like a few of those, let's say 3 elements. So these are like the 3 chunks that we have in this particular list, like the first 3. So we have this document metadata, we have the first chunk, and then here we have the second chunk, and so on. So this is how you can probably see this. Again, I'll probably comment this out. So if you want, you can run this and check this. The next step is storing this into ChromaDB. So but before that we need to convert this to vector embedding. So the next steps are load your vector embedding model, which is basically Hugging Face embedding, and then load this to ChromaDB. So you can say embedding is equal to Hugging Face embedding. Again, it's not like you have to use this particular Hugging Face embedding. So this loads the default Hugging Face embeddings, but there are also several kinds of vector embedding models in sentence transformer library. So you can use like any of those by mentioning that particular embedding model here. So this would probably take some time. So I've already loaded this, so this is not like taking that much time for me, but you can this probably take like a few minutes. So this is for the embeddings, and now I'm going to create a directory for my ChromaDB. So that will create a directory here, and that will act as the persistent directory. So the main difference here is that let's say you are using this FAISS library, which is Facebook AI similarity search, where it's going to create your vector embeddings in runtime, and it's going to do this vector similarity search. The problem with that is every time you're creating vector embeddings for your text and you're asking questions on it, and the thing with this vector DB approach is that you don't have to do this every time. So you can load this document once, and after that you can load this DB and ask questions like anytime you want. So it's like this process of creating embeddings and so on. So it's like you are saving this somewhere in a proper vector DB. So that's the main difference. So for that I'll create a variable called as persistent directory. So we call this as persistent directory because in the earlier versions of ChromaDB, you can say that I don't want a persistent directory. That means again, it won't kind of be present after runtime. but in this case we say that I want a persistent directory, that means it will always be saved. But actually in the recent versions of ChromaDB they have made that change where by default it's going to be a persistent directory. So here I'll probably call this as docdb, doc_db. So this will create a folder in the working directory. If you want, you can also give a different path where you want your persistent directory to be saved, but here I'll just do this docdb, which is the folder name. That's going to create a folder here. So let's run this. This is the variable name, and after that we can say vector db is equal to chroma dot from underscore documents. So here we have to pass in the parameters. So first parameter is documents, which is nothing but the text chunks that we have created as a list. And the next parameter is what's the embedding model that you are going to use. So this should be embedding is equal to this embeddings model. And then the persistent directory, persist is equal to, maybe you can use the same name of persist directory, the same name of this parameter over here. Instead of persistent, maybe you can use persist directory, and here also you can paste this. So the parameters are the documents that you want to embed, and like the embedding model itself, and what's the directory that you want to store here with ChromaDB. So let's run this, and this will also load our vector db to this variable called as vector db, the same name. So let's wait for this to complete. And here you can see you have this docdb, so you have like the folder where like all these things are stored and so on. Okay, so this is how you can store the vector embeddings in a ChromaDB folder. So now let's say this is done, and you can also create a new Jupyter notebook, and you can load your vector db. So maybe that we can see later, but for now we can just see in this code how we can ask questions and get an answer out of this. So now we have to create a retriever. So we'll probably put a comment here saying retriever. So this kind of used to retrieve, let's say the user is asking a question. So this is about transformer model, right? So the user is asking a question on what's the model or architecture represented in this paper, and now the retriever will find the content that's similar to this particular question. So it's like doing a similarity search, and let's say we have 26 chunks, and it says that 24 chunk is what kind of as the answer to that user's question. So this chunk is sent to the LLM along with the question, not the vector embeddings but the actual natural language text. So now the LLM looks at the question and the content in which the answer is probably present. Now using that, it will frame an answer and it will send you. So this is the concept of RAG. So it's not like we are sending the entire content, you know, like so we are not going to send the entire content. So that's the difference. Okay, so that's about it. Now in this retriever we can say vector db dot as underscore retriever. Okay, let's run this, and then we can load our LLM and create a chain and ask a question. So I can say LLM from Groq. So for this, create a variable called as LLM, which is equal to chat Groq, which is what we have imported from Langchain Groq. And within this model parameter, we can say Llama. So maybe I'll show you how you can do that. So in this Groq cloud, you have this documentation, and within that you can see like the different models that you have from here. So we have Llama 3.1 for 405 billion, which is the largest model that Meta has launched recently. But the thing is, it's available only for like paid users. So it's probably mentioned here, but we can use this Llama 3.1 70 billion version. So here I'll go ahead and copy this Llama 3.1 70 billion versatile. So this model ID is what you have to pass into this parameter called as model. So Llama 3.1 70 billion versatile. So the next is temperature. Again, there are like different parameters, you can search it. Maybe this temperature is what I kind of use in my videos. So it's like a simple parameter that dictates how the randomness of the response to be. So when a user asks a question, if the temperature value basically ranges from 0 to 1. So if the temperature value is 1, for the same question it's going to give you different kinds of answer, like it's slightly random. But when the value is closer to 0, it's going to give you like reproducible answers every time for a particular question. So that's about this temperature parameter. So similarly you have like different parameters that you can use that kind of makes the LLM give the response in slightly different manner. So here we have loaded our LLM. So here we are not loading the entire model itself, but it's kind of loading the API from Groq, using which we can access this Llama 3.1 model. So next is create a QA chain, that kind of where we would pass this vector DB retriever, this LLM and the user questions and so on, and that would give us the answer. So within this they have like configured prompts required for this doc QA, and all those things are present within this Langchain module. So I'll maybe call this as QA chain, which is equal to retrieval QA that we have imported here from Langchain dot change, and within this I'll say retrieval QA dot from chain type, and the parameters that we have to pass are LLM is equal to LLM and chain type. So there are also different chain types like stuff, refine and so on. So probably let's go with stuff, and then retriever is equal to the same name as what we have used, retriever. And there is another optional parameter called as return source documents. So this will kind of, when you make this as true, it will also have this parameter value in the output where it says like what's the source of this document. So in this case all the response is going to say that it's from attention is all you need .pdf, because that's the only file that we are loading. But the purpose of this is you can also do a multi-document drag where the content is present in like different documents. So in this case, let's say you want to know what's the source of this response from the LLM. In that case this will be like useful. So let's say that you have 10 documents and you want to know what's the source of the response that the LLM is giving. So for that you can set this return source documents is equal to true. So I'll run this, and this will create this retrieval QA chain with all these parameters from chain type and load this to QA chain. So now we can invoke the QA chain and get a response for user query. So I'll say query is equal to, I'll just ask a simple question, but you can also kind of use complex questions and see if the LLM is able to answer that. So what is the model architecture discussed in the paper? Okay, maybe put this as discussed in this paper. So this is the user question, and we will store this response in a variable, let's say called as response, which is equal to QA chain dot invoke, and within this you can send this. So the parameter, like you have to pass this as kind of a dictionary where the key should be the query and the value for this is like the query that the user is asking. So here we are passing a dictionary with key of query and the value of what is the model architecture discussed in this paper. And then you can probably, so maybe first let's print this one. Sorry, let's run this, and now it has like loaded the API and got the response. And the great thing about Groq is they are known for their faster inferences on this LLM. So you have seen that it didn't even take like 2 or 3 seconds. So that's like the great thing about it. But when you load it from Hugging Face or like LLAMA, there is a chance that it's going to take some time if it's the model is not properly distributed. But again, the USP of Groq is that they give this lightning fast responses. So that's about it. So we got our response, and again you can print this response and you will see like a lot of parameters. So you have this query, the question asked by the user, and then you have the result and so on. So if you want to print only the result, you can just say print response of result. So this is the result. So all other things are like the source document content and all those things. So it's like the source where it's present and so on. But this is the actual response. So it says the model architecture discussed in this paper is called the transformer. It consists of encoder and decoder and so on, which is basically is what's present there. And if you want to know the source, you have to extract this particular thing. in this metadata you have the source, attention is all you need, right? So for accessing that you can just say print response of source document, which is the key that has this particular value of 0, and dot metadata, and within the square bracket say source. So we are basically accessing this source documents key, and from that we are accessing this metadata, and from that we are accessing this source. So that's what we have given here. So when you run this, you will see this attention is all you need. So probably you can also put all these things together. So I'll copy this entire thing and say this, and maybe I can print the response. Let's print it over here, and let's maybe print some line breaking things. Let's say I'm going to print this asterisk for 30 times so that we know which is which response, and we can copy this, and you can also say that this is my source document. So when you run this, so you see the response model's response and it says source documents. Maybe we can put a colon here. Source documents is attention is all you need. So this is how you can kind of load this Llama 3.1 model from Groq, load it to a QA chain with Retrieval and all those stuffs and get a response. So this is how this is done. But there is one more thing to discuss. So here we have loaded this from ChromaDB, done all those things. But let's say that you want to do this again, but as I said earlier, you don't have to redo this part of reading the document, creating the chunks, doing the embeddings and so on, because we have already created the embeddings and stored this in this directory called as docdb, right? So now I'll tell you how you can create, let's say, a new notebook, and you can get this question and answer thing running quickly. Once you have this data stored, you can just do all those things simply. So I'll save this particular notebook, and I'll create a new one in the same directory so that I can access this docdb directly. So this is like let's say load the ChromaDB and get answers. So for this we need to like still import few things. Import OS from Langchain underscore chroma, import chroma to load the chroma model, and we still need the embedding because the user's question has to be now converted to embedding. So we don't have to convert the document into embeddings, but the user's question has to be converted to this so that it can do a similarity search of this question vector and the answer vector, or basically the document vector that's stored in ChromaDB. So for that we need this, and then from Langchain underscore Groq, import chat Groq, and finally from Langchain dot chains, import retrieval QA, the same thing that we have worked on before. Okay, so these are the things that we need, and now we have to store this API key in the environment variable as we have discussed earlier so that we can access the model. And the next step is you need to load this embedding model, which we have already downloaded from Hugging Face. So that's like the next step. So, and then we have to load this again. We can use the same code of persist directory. So make sure like you're passing the same name, which is docdb. It's not like you have to give this name, so this name can be anything. So you can run this cell and load this vector db using, so here we are creating this from documents, but now we don't want that. We need to load this ChromaDB, right? So for that you can say we'll create a command, say that load the ChromaDB. So here you can say vector db same name is equal to chroma, which we have imported from Langchain chroma, and within that pass your, let's say, persist directory, same parameter name, and your embedding model. Sorry, you need to mention this as embedding function. So embedding function is equal to your embeddings, the Hugging Face embedding, And when you run this, this will load the ChromaDB that you have created into this particular variable called as vector.db. And other things are like pretty straightforward, pretty same of what we have did before. So you can just use this as like retriever, and within this also you can give different parameters that kind of changes the way the data is retrieved, so on. And now here we can load the LLM and maybe run this last thing of asking a question and getting a response. Oh, we have to create the QA chain, sorry. So I'll copy this and paste it over here, and finally run this. So here we would get a response. So this is how this entire thing kind of works, where we don't have to now create those chunks, convert the document text into embeddings and so on, because we have already done that and stored that to the docdb folder, which is basically a ChromaDB folder. And then we can load this to vector.db, use that retriever. LLM can be loaded with chat Groq, QA chain, and so on. So this is how this can be done. Maybe I'll just give you a quick recap of whatever we have done. So first thing is like we have installed all the libraries, imported all the required dependencies, and the next step is getting this API key from Groq cloud from over here. And once that's done, we are storing this in the environment variable of Groq API key. So the next step is reading the PDF file and loading it using unstructured file loader, or even you can use unstructured PDF loader. And we are creating a character text splitter with different chunk size, chunk overlap, and so on. And then we are splitting the documents text into different document pieces, and then we are loading the embedding model, creating a persistent directory for our ChromaDB where the vector embeddings will be stored, and we are passing the documents chunks, and then we are passing the embeddings as well as the persistent directory. So the next step is setting this vector.db as retriever, which will pass later to the QA chain, and we are also loading this Groq API for using Llama 3.1 70 billion version. And then in this QA chain, we are passing this LLM chain type retriever and also parameter to return the source documents itself. And then the user can ask a question, and we can extract the result and the source documents as well. So if you want to do this the next time, you can just like load the previously created docdb, and then you can get a response and all those results. Okay, so this is how you can build a RAG framework, basically using ChromaDB as your vector store and LLMs from Groq. So again, few things like won't differ much. So let's say that instead of Groq, you want to use LLAMA. So in this LLM part, right? So here we are using Langchain, Groq, chat Groq. So instead you can use there is also a version of chat LLAMA from Langchain. So you can like use that as well. So instead of using this chat Groq, let's say you have Gamma 2 billion or some other smaller models in your local machine, you can use that as well. Okay, so that's how you can perform this. So I hope that this is useful to you, and please try this code and let me know if you have any doubts in the comments. So that's it from my side, and I'll see you in the next upload. Thanks for watching.